There are three properties of logarithms that you really want to know, and these really shouldn't be that big a deal to keep straight. As long as you understand that logarithms are exponents, this is very similar to applying exponent rules. So if m, n, and b are positive real numbers, b is not equal to 1, and p is any real number, then we have some different things that can happen. Okay, and the first one we're going to look at is the product property. And it doesn't matter what the base is. If you have a logarithm where you're multiplying two real numbers together, and that does include variables, then these two things are equivalent. Okay, now think about what happens when you're multiplying like bases. You add the exponents. So kind of think of that in the same way. When we're doing the product property, that means we can change it to adding. So let's see what we can do when we're applying the product property here. So in this first example, we have log base 2 of 4x, and this can be rewritten as log base 2 of 4 plus log base 2 of x. Okay, now we're going to use all this stuff to solve equations, and so depending on what you're starting with in an equation, you may want to go back and forth in between these two things. So let's make sure that we can do the other direction also. This works because the bases are the same, and the bases do have to be the same for this. So log base b of 7 plus log base b of 5 can be rewritten as log base b of 7 times 5, which can be written as log base b of 35. So let's take a look at the quotient property. And again, think about your exponents. If you are dividing like bases, you subtract the exponents. And a logarithm is just an exponent. So when we have the same base, right, we can say log base b of any two numbers divided is the same as log base b of the numerator minus log base b of the denominator. So we're going to go in both directions here with the quotient property, just as an example to show you what's going on here. So the first one, log base t of 6 divided by u, right? We can rewrite that as log base t of 6 minus log base t of u. Okay, and likewise we'll go in the opposite direction here. And again, the bases have to be the same for this to work. Log base b of 17 minus log base b of 27 can be rewritten as log base b of 17 divided by 27. So here's the power property. And remember, when you are raising an exponent to an exponent, a power to a power, that means you multiply those exponents together. And you see here we have log base b of some number raised to an exponent. Remember, a logarithm is just an exponent, so then we're going to be able to take that out front and multiply the two things together. So the exponent times the logarithm base b of the base of m. So when we apply the power property to this situation, log base a of 9 raised to the negative 5th power, if we wanted, we could write it as negative 5 times log base a of 9. Okay, and if we wanted to go in the other direction, we have 3 times log base b of 2. We could rewrite that as log base b of 2 to the 3rd power, and we could reduce that or simplify that to log base b of 8. So let's look at some situations where you could use all the properties working together. And this is just an intro to using these properties to solve equations. So you'd have to kind of determine when and how you'd want to use all of this. But we can rewrite these in some expanded form. You just have to, kind of take one thing at a time. The first thing I'm going to look at here in this problem is that we have a division problem. So I'm going to rewrite this as log base b of x cubed minus log base b of y times z. Okay, and just like any other time you have a subtraction sign, be very careful what's going on, and just make sure your signs get to be correct. But this first term now can be simplified a little bit further because of this exponent. So I'm going to take the 3 out front, and now we have 3 times log base b of x minus, and I'm going to use some parentheses here because we are going to do the product property, and so then we can rewrite this as log base b of y plus log base b of z. Now that's pretty good right there. We could kind of simplify it a little bit further, but just remember, negatives are really tricky and you got to really watch. And we have this parenthesis, so really it's like distributing a -1 to both terms inside. So we can write this as 3 times log base b of x minus log base b of y minus log base b of z. For this example, the first thing you're going to want to do is change our radical here into a rational exponent. So remember, you do that. This would be the 4th root, so now we have log base a, and I'm going to use parentheses here, and all of this is to the 4th root. Now you don't want to make this complicated, so anytime you can mess with your exponent right away, we should do that. So I'm going to take this 1/4 out front and have 1/4 times log base a of xy over z cubed. Now, just like in the previous example, this 1/4 applies to everything. Okay, and so we can just take care of that pretty simply by using parentheses. So I'm going to say 1/4 parentheses, and now I see this division. So I'm going to say log base a of xy minus log base a of z cubed. Now I'm going to, in the same step, I'm going to change this. This is multiplication, so we'll get 2 logarithms added, and then I'm going to bring the 3 exponent here out front. So we would have 1/4 times log base a of x plus log base a of y minus 3 times log base a of z.